In the mid-1930s, the theoretical ideas of Italian General Giulio Douhet gained extraordinary popularity in the Western world. According to them, tanks and infantry in the battles of the future would play only a supporting role. The main weight of the struggle shifted to the air. At the same time, victory over the enemy was to be achieved through continuous bombing offensives. How seriously this turn of events was taken can be judged by the fact that almost all leading powers in the interwar period acquired, or at least actively developed, specialized high-speed interceptors. The United States was no exception. Already in February 1937, the headquarters of the U.S. Army Air Corps issued technical requirements for such a fighter. According to specification X608, the military wanted an aircraft with a maximum flight speed of about 570 kilometers per hour and a ceiling of 12 kilometers. Since the primary targets for the required airplane were supposed to be highly survivable multi-engine bombers, the armament was expected to consist of a powerful set of two twin machine guns of 12.7 and 7.62 millimeters caliber. Soon, all leading aircraft manufacturers in America joined the race for the lucrative contract. However, quite unexpectedly, a swift victory in the competition was won by Model 22 of the Lockheed Aircraft Corporation. A certain role in the rapid adoption of the positive decision was undoubtedly played by the eloquent statement of the company's head, Alan Lockheed, that their winged creation would in the future easily surpass the 700-kilometer barrier. However, even without loud words, the machine indeed turned out to be very promising. And this was not only about the unique and recognizable appearance, which was the result of the imagination and deep knowledge of chief designer Kelly Johnson. The aircraft, later designated the P-38, was, without exaggeration, literally packed with innovative solutions for its time. For example, it was the first of its class to employ a tricycle landing gear with a nose strut, slightly ahead in this regard of Bell's P-39 Airacobra. Another innovation was the use of hydraulic boosters in the control system, which significantly reduced pilot fatigue. But the main effort, of course, was directed to solving the primary task of any fighter, achieving the maximum possible speed. Thus, the Allison V-1710 engines chosen as the power plant were, for the first time in the world for a production aircraft, equipped with turbochargers, and the entire duralumin skin of the airframe was attached with flush riveting. Moreover, wherever the calculations allowed, the skin panels simultaneously performed the role of load-bearing structural elements, thereby partially replacing the classical framework of welded steel tubes. Kelly Johnson also solved the problem of heat dissipation from the red-hot turbines in an original way. The engineer routed the cooling system pipelines through the wing leading edges, thereby also almost eliminating the effect of icing during long flights at high altitude. The first XP-38 prototype was ready in December 1938. After a brief stage of ground testing, on January 29th of the following year, Lieutenant Benjamin Kelsey took the experimental machine into the air. That first flight was not very successful. The flaps jammed. As a result, the Army pilot was forced to land the P-38 at a high angle of attack, damaging the tail unit against the concrete runway. However, the mishap was soon forgotten, because already on its fifth flight, the experimental machine demonstrated a maximum speed of 660 kilometers per hour, which was nearly 100 more than the value required by the military. Inspired by the success, the developer decided without delay to aim for the Trans-American speed record. The same Lieutenant Kelsey volunteered to pilot the aircraft. The entire flight went smoothly, but at the moment of landing approach, the fighter's right engine suddenly failed. As a consequence, with no reserve of speed and altitude, the pilot made an extremely hard landing on a golf course. Benjamin Kelsey survived, but the aircraft had to be written off. The loss of the first prototype, together with the lengthy mastering of a huge number of technical innovations, delayed the refinement and adoption of the fighter into service by more than a year and a half. As a result, the P-38s reached the troops only in June 1941. The aircraft of the first truly mass-produced D-series, in addition to the 4 previously mentioned machine guns, were equipped with the 37mm M9 aircraft cannon with an ammunition load of only 15 shells. The weight of the armament, multiplied by armor, radio equipment, and self-sealing fuel tanks, had the most negative impact on the agility of the winged machine. Thus, the fighters delivered to the Army, despite somewhat more powerful modifications of the Allison engines, did not accelerate beyond 630 kilometers per hour, though even that was considerable. It must be said that the progress of tests of this unusual aircraft was closely monitored in many leading countries of the world. In particular, it is known for certain today that Soviet intelligence already in 1938 managed to steal from Lockheed a complete set of technical documentation for the so-called Model 22. I believe it was by no means the least factor that this information obtained through secret channels served as a push for initiating similar developments in the Soviet Union. I mean the soon-appearing projects V-100, MiG-5, and OK-6. With no less enthusiasm, the military of the British Empire responded to the overseas novelty, ordering 400 twin-engined aircraft as early as the end of 1939. The British planned to use the heavy aircraft mainly as a fighter-bomber, so it was decided to abandon the maintenance-demanding turbochargers. In general, the British colleagues did much useful work in improving the Lightning, as the P-38 was called on the foggy Albion. In particular, it was their engineers who, after studying the drawings, recommended redesigning the originally not very successful nose gear unit, moving the hydraulic cylinder directly into the inner bay, and using the freed space to increase the ammunition load. They also insisted on replacing the temperamental M9 cannon with the much more reliable 20mm Hispano Suiza. But most importantly, it was on the export Lightnings that, by changing the junction shape of the wing and fuselage, they finally managed to cure the extremely dangerous buffeting of the elevator. All these innovations, except perhaps the rejection of the high-altitude turbocharger, were later successfully implemented on the fighters produced for the American Air Forces as well. As for the British, they had to wait 2 whole years for their aircraft. When the machines finally arrived, they were test-flown by the pilots of the Farnborough Testing Center. The verdict was unexpected. It turned out that there was simply no suitable niche for the P-38 in the Royal Air Force. But on reflection, such a turn was easily explained. In 1942, the RAF already had an excellent alternative: the de Havilland Mosquito, against which the speed characteristics of the turbochargerless American fighter no longer looked so impressive. As a result, the order was canceled. The fate of the twin-engined aircraft at home developed quite differently. As you all know, the war for the United States began with the devastating defeat at Pearl Harbor. Fortunately, there was not a single Kelly Johnson fighter among the bombed-out stands of American airfields in Hawaii and the Philippines. With the beginning of the war, all available P-38s, as some of the most valuable aircraft, were concentrated exclusively in squadrons along the west coast of the United States. It was there that their combat debut took place. This happened on August 4, 1942, when a group of 4 high-altitude interceptors on patrol over Alaska managed to shoot down 2 enemy Kawanishi H-8K Mavis flying boats. Soon after, the Pacific Theater of Operations would become the main stage for this aircraft. At the peak of its activity, 80 squadrons of Lightnings would be fighting here simultaneously. The high ceiling and great speed made this heavy fighter an extremely dangerous opponent for any Japanese aircraft throughout the war. In clashes with the opponents of the land of the rising sun, American aviators adhered to a simple but no less effective tactic of hit and run. The flight manual for P-38 pilots directly forbade them from engaging in dogfights with Japanese fighters, which had undeniable superiority in horizontal maneuverability. But the main trump card of the Lightning was, of course, its impressive range. When using 2 drop fuel tanks, the aircraft could remain in the air for as long as 10 hours, covering 3,000 kilometers in that time. You may be surprised, but even that was not enough for some generals in Washington. For some time, Lockheed seriously considered a variant with a jettisonable undercarriage bay, the cavities of which were also planned to be used as an additional fuel tank. According to preliminary calculations, in this case, the expected non-stop flight range increased by at least another 1,000 kilometers. But apparently, the sober realization of the physiological impossibility of piloting the machine alone for so long eventually prevailed. Be that as it may, it was precisely the impressive combat radius that allowed Lightnings, at a distance of almost 900 kilometers from their own base, to intercept and destroy a Japanese bomber flying under strong fighter escort, on board which the commander-in-chief of the Imperial Japanese Combined Fleet, Isoroku Yamamoto, met his death. The improvement of the machine continued throughout the war. With the F modification came the ability to carry a pair of 450-kilogram aerial bombs on the center wings, and so-called combat flaps were installed in the wings, intended by analogy with the Ki-43 to improve maneuverability. In June 1942, the G version began to enter service, its distinctive feature being more powerful engines. However, there was little practical benefit from this innovation, since the manufacturer had not managed to refine the engine cooling system. As a result, flying at full throttle was impossible. Nevertheless, all shortcomings were eliminated in the next J series. Aircraft of early 1943, thanks to another round of engine boosting, became the fastest Lightnings. At an altitude of 7.5 kilometers, the 8-ton machines reached 670 kilometers per hour. An important innovation was the appearance of dive flaps, which forcibly limited diving speed. This was done in response to repeated reports from the front in which pilots complained about low efficiency. According to them, during prolonged dives at near maximum speed, the aircraft turned into something resembling an uncontrollable stone. This feature was readily exploited by Luftwaffe veterans who preferred to lure inexperienced American pilots into steep descents from high altitude during retreats. Yes, do not be surprised. Despite the British rejection of the aircraft until Mustangs and Thunderbolts appeared in sufficient numbers, the P-38 was actively used as an escort fighter for Allied bombers during their raids on the industrial facilities of the Third Reich. In this theater, the Lightnings were based at airfields in North Africa and the eastern part of the British Isles. The work of covering bomber formations was extremely dangerous, for to be honest, German aircraft of that period were in many respects, including speed, quite comparable to Lockheed's twin-engine machines. To confirm my words, I will cite statistics. At the cost of losing 1,800 Lightnings, 2,000 Luftwaffe fighters were destroyed. And besides this, one should not forget that many stars painted on the striped fighters were earned against the fire of anti-aircraft artillery. The L series, which appeared at the beginning of 1944, could boast a wide variety of hardpoints, allowing the airplane, in addition to the now traditional set of bombs and drop tanks, to carry up to 14 to 127 millimeter unguided rockets if necessary. A not insignificant innovation for its time was the equipping of some aircraft with compact AN/APS-13 radars. This equipment, scanning the rear hemisphere automatically at a range of up to 700 meters in the event of detecting an unknown aircraft, warned the pilot of danger from behind, transmitting a characteristic sound signal into his headphones. In general, in Europe, starting from 1944, the Lightning was increasingly used as a fighter bomber. The later modifications could carry a truly fantastic load. It is enough to say that if necessary, a pair of aerial torpedoes or bombs with a total mass of about 2 tons could be suspended under the center wing. In principle, the only thing preventing the P-38 from being used as a full-fledged bomber was the absence of a standard bomb sight. But even this turned out to be solvable. Colonels Kess Howe and Dan Ostringer modified the nose section of the airframe, removing all the forward-firing armament and installing in its place a bombardier navigator. Aircraft modified in this way received the designation Droop Snoot. These machines were used as leaders, from whose command the other Lightnings of the group released their bombs. The next stage in the evolution of the Droop Snoot was the Pathfinder. This aircraft carried even more advanced targeting equipment, which provided the ability to safely bomb from behind cloud cover. To be fair, the idea of using the compartment intended for forward-firing weapons for a different purpose was born much earlier than the proposal of the two colonels. The high flight performance and considerable range themselves pushed the military toward employing a disarmed Lightning as a tactical reconnaissance aircraft. And here the machine found success, perhaps even greater than in all its other roles. Thanks to the unobtrusive work of reconnaissance squadrons, the landings in Sicily and Normandy became possible, as did the successful Allied offensives in France and Italy, along with most other operations. It is no surprise that despite the Army's extremely limited need for reconnaissance aircraft, by the end of the war, every 8th twin-engine Lockheed leaving the assembly line was equipped not with machine guns but with photographic equipment. Friends, when I first began to take an interest in aviation technology, I, like quite a few of my viewers today, was convinced that a heavy twin-engined aircraft was by definition incapable of effectively fighting against more agile opponents. But today, having acquired some measure of knowledge, I am forced to admit that I was wrong, and the story of Kelly Johnson's Lightning is vivid proof of this. The P-38 Lightning became a true forge of aces in fighter aviation. It was precisely on this aircraft over the vast expanses of the Pacific Ocean that Richard Bong and Thomas Maguire fought, who by the end of the war had become the most successful pilots of the United States Army Air Forces. For my part, I cannot help but feel that this remarkable aircraft, more than any other, most accurately embodies both the impressive economic power of its country and the beauty of its engineering thought. Thank you for watching, and we will meet again very soon.